Alright, so for this one, we're going to try to find the Norton equivalent circuit at terminals A, B of the circuit here. So a Norton circuit is almost exactly the same as a Theravin, except it's with current. The Theravin circuits are with voltage. So we're going to try to turn this into something that looks like this. We're going to try to turn this into something with a current source, and that's in parallel with some resistor. And then there are two terminals over here and over here. We're going to try to find what this current source and this resistor is. And so to me, this is kind of like, it's kind of the same thing between the two, because remember, you could always do a source transformation if you find one and pull it to the other one. So it's kind of straightforward. We're going to go through and solve this. I'm going to move my camera a little bit so we're a little more even. There we go. All right, so let's begin to solve this one. Trying to get, again, a current source in parallel with the resistor, which, again, we could take a source transformation and put that as a voltage source in series with the resistor. So let's begin. So for this one, our first thing that we're going to do is we are going to do our node voltage one. I'm going to write a little small on this one. Node voltage method. So that's going to be, we're going to make our V1 and we're going to make our V2. Okay? And then from those, we're going to draw out our I1, I1, I2, I3, and I4. And we're also going to draw out our I5 and our I6. Okay, so I think that's all of our nodes. Yes, we only have those two. Cool. And so the next bit we're going to do at node method at V1. I'm going to do that. So we've got I1, I2, I3, I4. So I1 plus I2 plus I3 plus I4 equals 0. Same cool deal. Awesome. So our I1, we're going to look here. That's going this way. That is V1 minus, what is that? V1 minus 15 over 3. V1 minus 15 over 3 plus our I2 is V1 minus 0 over 6. So V1 over 6 plus our I3 is going to be, we already are given a dependent current source here. So our I3 is going to be in the wrong direction, so negative 1.2 I0, negative 1.2 I0, and then plus our I4 is going to be V1 minus V2 over 4. V1 minus V2 over 4 equals 0. So what's our least common? So we're going to multiply this by 6, and that's going to be right here, what? 2v1 minus 30, and then the next one is plus v1, and the next one is 6 times 1.2 is going to be 7.2, so minus 7.2 I0 plus, and this is going to be 6 over 4, so 6 over 4 is 1.5, I think. Yeah, 1.5. So this is going to be 1.5 V1 minus 1.5 V2 equals 0. Let's collect terms. We got 2, 3, 4.5 V1, 4.5 V1. Plus, what do we got here? Minus 1.5, so it's just plus negative 1.5 V2. And then we got another negative 7.2 I0. And then we're going to pull the 30 over the other side, 30. Okay, so that's our first equation. We're going to box it. All right, just give you a second because I might have shown up that whole one. All right. So our next equation that we're going to have, we have 1, 2, 3 unknowns, so we're going to need 3 equations. So 2 node voltage at V2. So let's go to V2. V2 is a little easier. That's nice. So we're going to get the I5 plus I6 equals 0. That's not nearly as bad. So that's going to be I5 is 1.2 I0, so 1.2 I0 plus, this is going to be V2 minus V1 over 4. V2 minus V1 over 4 equals 0, so we're going to multiply by 4 to bring that up. So that's going to be 4 times 1.2, 4.8. 4.8 I0 plus V2 minus V1 equals 0. That looks good too. So that's our second equation. And now we have 3 equations, 3 unknowns. We need our last equation, and that we can get from I0. So what is I0 going to be equal? 3 at I0. And I0 is just going to be, what do we got here? We've got our V1. We've got a 15 before ground, and we got a 3. So we're going to be able to plug this in as I0 equals 15 minus V1 over 3. Again, we are going in this direction. So 15 minus V1, whatever that is, over the resistor in between the two is 3. So that's our third equation. So that's going to be equal to what? 3I0 minus plus V1 equals 15. That's our third equation. So now that we've got those in, oops, sorry, couldn't see that for a minute. We'll pop it back up. Now that we've got those in, we're going to make our matrix over here, which is going to be our 3 by 3 to solve, and our 3 by 1. All right. So we've got our first one, 4.5. Our second one, minus 1.5. Our third one, minus 7.2, minus 7.2. And that's going to be to 30. We've got our minus 1. We've got our 1. And we've got our 4.8. And that's going to be our 0. And now we've got our V1, 1. We've got a 0 for V2. We've got a 3 and a 15. All right, so let's do these up online. Let's turn my calculator on. Can we see that screen? I don't know. Let me see if I can see it. Hang on, give me a second. Yeah, it's okay. It's not the best, but it's okay. So let's do this. So we've got second math matrix, edit. I'm going to do a 3 by 3, and we're going to do a 4.5, a minus 1.5, a minus 7.2, and then a minus 1, a 1, a 4.8, and then a 1, a 0, and a 3. Cool. A matrix. We're going to do an edit. We're going to go to this. We're going to do a 3 times 1. For this one, we're going to do a 30. We're going to do a 0. We're going to do a 15. Quit. Math matrix. A minus 1. Math matrix. B. 10, 2, and 1.67. This is 10, 2, 1.67. And that means this is V1, V2, and I0. Awesome. So, now that we got those, now we're going to do kind of a special thing for for Norton circuit. So what we're going to do for Norton, we're going to come back up to the drawing up here. We're going to draw something theoretically connecting these 2 bits. This is just for calculations. We're going to call it ISC. And this is saying if this is closed, how would the current be flowing through here? And that way we can get our current coming out. Because again, we have to calculate this out in the long run with 2 open terminals. So in order to calculate out what all is going on here, we have to close it off for a minute. So we close it off, and now we're going to do kind of the same thing that we did before. We're going to just do a little line going down here. And we're going to use some of our values from over here later on to be able to calculate out this Norton circuit. So let's try this one more time. We're going to do a 1 node voltage at V1. And so if we look at it now, since this is closed off, this is going all the way down here to ground, so we're not going to have to count V2 anymore. It's just going to be V1, okay? Because it's going to go, see, from here all the way to ground. So V2 doesn't exist anymore on the second part of this. So that's going to change our answer slightly. So let's do this. We've got I1, I2, I3, I4. We're going to recycle them. I1 plus I2 plus I3 plus I4 equals 0. We're going to plug these same ones in. Our I1 is going to be V, okay, minus 15 over 3. V minus 15 over 3. Cool. I2 is going to be V1 over 6. V1 over 6. And this is V1 too. Our I3, now this is going to be our minus 1.2 I0, minus 1.2 I0. And our I4, so this is the one that's going to change because we used to have V1 minus V2, but now we don't have a V2 because it's going to go right through here through to ground. There's nothing, it's not stopping anymore. It's just going to ground. So we're going to have, for this one, we're going to have our V1 over 4. It's going right to ground, equals 0. Going to multiply this out by 6 in order to make it nice and neat for us. And that's going to be what? 2V1 minus 30 plus V1 plus 7.2 minus plus negative 7.2 I0 plus 1.5 V1 equals 0. Collect like terms. We're going to get our 4.5 minus 7.2 I0, so that's 4.5 volts, minus 7.2 I0 equals 30. 30 goes over, V2, 3, 4.5 minus 7.2, and 30 drops over. Cool. Equals 30. Let's box that. That's our first equation. Now we're going to go for our second equation. So we have V and I0. So now we have to calculate I0 now that we've closed this off. So our I0 is pretty easy to calculate, actually. It's the same kind of deal. I0, so let's look with the current coming in. We have a voltage and we have a resistor. So I0 has to be equal to 15 minus V divided by 3. See how that works? 15, because we have the source coming, minus V, V1, whatever you want to call it, over 3. And so that's our second equation, so we're going to rewrite that out, which is going to be 3I0. What does that? Move that over. Plus V1 equals 15 as our second equation. So now we're going to have to solve a 2 by 2. So the 2 by 2, we're going to get 4.5. Let's just do this. Minus 7.2, 4.5, 7.2. And this top part equals 30. Okay, and then this one we're going to get over here a 1, a 3, and a 15. Okay, and that's going to equal something. Let's do it on our calculator real fast because I don't know what it is. Second matrix, edit a 2 by 2, and we're going to do 4.5 we keep in minus 7.2, and this is going to be a 1, and this is going to be a 3. Okay, I'm going to quit this, quit, and then we're going to do a math matrix. I'm going to edit the 3 by 1, make that a 2 by 1. And then for this, we're going to do 30 and then a 15. Okay. We're going to quit. We're going to do a second math. This minus 1, second matrix B. What do we got? 9.56 and 1.8. 9.57 and 1.81, and that equals V1, and that equals I0, or I. Yeah. So we're set with that one. Cool, cool, cool. We've got that part. So now that we've calculated if it's in and when it's not in, when that ISC is in, now we can kind of go back and kind of calculate out the current coming down this to be able to solve what our initial value is. So we have I0, we have V. So right now we're going to do ISC, so the current coming through this wire right here is going to be equal to V over 4 minus 1.2 I0. So where do we get that from? So if we look at this node right here, so now we're going to look at this this current divider because it's dividing the current from 1 to 3. So we're going to look right at here. ISC ins are going to be equal to the outs. So we've got our V over 4, and then we've also got this one going in this direction, which is just the current coming through here. So ISC equals this coming this direction and this coming that direction, which is actually coming in the reverse direction. And this is going down. So this is down, this is in, this is out. All right, so this is down, this is in, and this is out. Okay? So now we can solve for this using the value that we just had before. So let's plug this in again. So we've got our V, and we're going to plug through. V equals 9.57 divided by 4 minus 1.2. And that's going to be, what is I0 again? I0 is 15 minus, whatever we got here, 9.15 minus 9.57 divided by the resistor here, 3. Okay? And if we calculate this out, let's do it real fast. We've got so this is going to equal 0.22 equals ISC. 0.22. So we're going to save that. Okay, that's important. Now we're going to calculate our, let's pull this up a little bit so we have a little more room. Our Theravin resistance equals, V equals IR. So R equals V over I. And that's going to equal 2 over 0.22. And where did I get this 2 from? Where did I get it? I got it from over here, from where we solved it before. This is V2 over 2. So let's look. Our equivalent resistance right here. That's what we're looking for. So let's pull this one out. And this is going to be 2 divided by 0.22 equals 9.1. Okay, so we solved that one. And now the last bit of this, do we need anything else? No, we don't. That's everything that we need right there. So our resistor comes back up over here. Can we see that? Yes, 9.1. And our 0.22 is our source. 9.1, 0.22. So we can draw that one more time down here if we want just a cleaner drawing. We've got a current source in parallel with a resistor, and this is 0.22. This is 9.1. We've got our 2 terminals still. So that is how you solve these. We can go through a couple more if you ask. Yeah, let me know what you need.